Hello everyone, this is the assignment from yesterday, problem number 45, which reads this, that Susan's 10-kilogram baby brother Paul sits on a mat. Susan pulls the mat across the floor using a rope that's angled 30 degrees above the floor. The tension is at a constant 30 newtons and the coefficient of friction is at 0.20. Use work and energy to find Paul's speed after being pulled 3 meters. And so first thing just to write down the givens. So we have the mass at 10 kilograms and displacement of 3 meters. Initial velocity, I'm assuming, is at a rest at 0. And so we have the floor along here. The tension is 30 newtons at an angle of 30 degrees above the horizontal. We're also told that the coefficient of kinetic friction equals 0.20. And what we're looking to find here is the final velocity. What does the final velocity equal? And we're using work and energy concepts here. And so the first thing is to take a look at, well, the displacement is 3 meters, so it's horizontally 3 meters along the ground here. So I need to know, in order to find the work done by that tension, one way to find that is to just look at the tension that's parallel to the direction of motion. And so I'm going to write here that tension parallel to the direction of motion is going to equal, well, if this is 30 degrees here, it's going to be this component right there. So that's going to be equal to tension T times the cosine of 30 degrees. And if you actually calculate that out, that equals 25.98 newtons. All right, so that means that the work done by the tension is equal to the work done by the tension that is parallel to the direction of motion. So that's this here. So the work done by the tension is equal to the parallel component, 25.98 newtons, times the displacement, 3 meters. And so that equals 77.94 joules. And this would be the change in kinetic energy, except for we have friction. So friction is pulling energy out of this. And so friction does negative work. And so to calculate the work done by friction, that's going to be, well, it's going to equal the force of friction times the displacement of Paul here, which is still at 3 meters. And I'm just going to, the direction of the friction is in the direction opposite to motion, so it's the sine of 180 degrees. So it's going to be a negative value. I also know that the force of kinetic friction is equal to mu sub k times the normal force. So if I continue writing what this work is equal to, it's equal to negative the force of kinetic friction times the displacement. We're given the force of kinetic, or the coefficient of kinetic friction. We don't know the normal force. We are given that delta x is 3 meters. I can quickly figure out what the normal force is. If I do a little side diagram over here, what are the forces acting on this object? Well, we have the force of gravity, this object being Paul, I guess, which is equal to mg. We have the tension, which is 30 newtons, like that, 30 newtons at 30 degrees above the horizontal. And we have the normal force. So in the y direction, the sum of the forces in the y direction equals the normal up plus the tension in the y direction up. So that's this component right there. Subtract mg. And so you can, and this is all going to equal mass times acceleration in the y direction, which all equals 0. So if all of this here equals 0, I can solve for the normal force, and when you calculate that through, you'll get that that's 83 newtons. So you can plug that 83 newtons in to here. You can plug 0.2 in for here. And our delta x is still the 3 newtons, or excuse me, 3 meters. And so you get that the work done by friction is equal to negative 49.8 joules. So you have positive work done by the tension in the rope, negative work done by friction. Well, the change in kinetic energy is going to be equal. Remember that the net work that is done on an object is equal to its change in kinetic energy. So if I combine those two works, the positive work and the negative work, I end up getting, in the end, a value of 28.14 joules. And so that's the change when you combine those two. And so that equals kinetic final, subtract kinetic initial. Kinetic initial was 0. So this really all equals 1/2 mass times final velocity squared. So all of that equals 28.14 joules. We know that mass equals the 10 kilograms that was given. So you can solve for final velocity and get 2.37 or 2.4 to 2 sig digs meters per second for your answer there. So this is taking advantage of the work kinetic energy theorem. All right, so what you're going to have now is Mr. Goldhammer will hand out the Unit 4 review, which will cover the chapters 9, 10, 11. Pay close attention to this sheet as it illustrates and points out which sections you're going to be responsible for in the test. It also points out the chapter summaries. Note which sections are omitted from the chapters that we're going to be covering as an extension after the test. And also note the example questions that I point out. Those would be good to look at and to maybe work through. You also have 5 review questions. Now they're going to take a while to do, especially number 4, but please take these seriously as these are really going to help prepare you for the test. You have plenty of time to do this because the test isn't until next Tuesday. So please take full advantage of this time to work on these problems. Tomorrow, Friday, there will be a video on greatest discoveries in physics and a worksheet that goes with that, but no additional homework. It'll just be the continuation of the work on these review questions. Also, the answers to these review questions will be posted up on Moodle, the solutions, not just the answers, but how to go about getting the answers. So the point is not that you just have a completed sheet of paper, but that you use this to really help prepare you for the test. Again, test next Tuesday, and hope you have a great weekend, and I will see you next week.